All right, so we will start what is container. So definition is very simple. A container is lightweight, standalone, executable software unit that package code and all its dependency. So application runs really reliably, access different computing environment. All these line by line you'll understood in few minutes. All right. So next thing is basically it is, it's a very weird example I like to give you, but just try to understand. Its container is something like your tiffin box. Okay, why it's your tiffin box? Say tiffin box. Remember, when we used to go to school, like we have a tiffin box. Even in office, if you're going, in tiffin box, what we have like all the things, whatever is required inside that tiffin box. Whatever you want, everything is contained within it. Okay, you're not taking your kitchen along with. You're just taking whatever is required along with you. So it's something like that. I know it's very weird example, but what it is right now. So let's move ahead with this. So we discuss about what is this container and all. Now what we are going to do is we will discuss about the type of container. Okay, this is what is container. That is fine. Let's discuss about the type of containers. What are the different options of containers? Alright, so type of containers. So there are different types of containers available. Okay, one of them is very famous is Docker. Okay, so Docker is one of the type of container. Okay, but Docker becomes so famous that it's a synonym for container, but it is not. Okay, it is one of the type of container. The Docker is basically their container name is also Docker. The company name is also Docker. Okay, Docker Inc. is the company, but their container name is also Docker. Okay, so Docker is one of the type of container. Okay, that is very, very popular. As I mentioned, it's almost synonym. People don't say container. They will say I want to learn Docker. They won't say I want to learn container. So that much popular. Okay. Second, you can say there is another option that we call Podman. There are another option that we call container D. There is another option that we call CRIO, C-R-I-O. Okay, so is the Docker who invented container? No, actually Docker did right thing at the right time. That's it, and that is why they become very popular. The concept of the container is like quite long. If you have somebody coming from Linux background, they may be knowing it LXCs, Linux containers, right? LXC and LXD. So these are some of the containers option that are. This concept was already available. There is a concept of jail in Linux. Okay, that is also some kind of a containerization only. Jail concept was like we create an environment, something like that environment we create all the dependency in this environment. And we put like this is there, and Solaris was an operating system that were having the concept of zones, right? I started using zones somewhere in 2007 or something. Okay, so this is something where those similar concepts were already available. The only thing what I'm trying to say is this become very popular after when Docker came up with a solution. Okay, so these are the different types of container. Even Windows doesn't have as a native concept of the container, but they use a virtual environment on top of it. We can run container. So these are some examples of types of container. We will be focusing only on Docker. We will discuss Docker only. Okay. And so for that, what we are going to do is we are going to run. What we are going to do, we are going to install Docker. Okay, when we'll install Docker, then we will learn some basics commands of Docker, and then I will explain you what actually is container. Okay, the definition that we have written here, that is fine, code plus dependency, that is absolutely fine, but technical term, what actually is a container, that we'll try to understand. For installation of Docker, what we will do, can we install anywhere? Yes, you can install anywhere container, Docker. What I am going to do, I'll take a Linux machine. Okay, over this Linux machine, I will install Docker. Okay, and whenever this is going to be, this process we will always follow. Whenever we have to install anything, or in your life, in your in your job also, if you have to install anything, the best approach is follow the documentation. Okay, follow the doc. And for Docker, the best documentation that is available is docs.docker.com. Okay, you will get everything there. You can go to docs.docker.com. Not now. Okay, so this is the place where you will get all the things related to Docker. Okay, get started and all. Okay, like Docker Desktop is one of the version, you can install on your Windows machine. It will install. You can install on Linux as well. So what are these Docker Hub, Docker Compose? We'll learn all those things. But this is one of the place where you can install. Okay, and there is one more thing. Let me go to get started. That I will tell you. There is an okay, it's not mentioned here. So there is a link that you can say play-with-docker. Okay, this is play with Docker. This link that you can use, okay, to play with Docker. Play with Docker means you can log in to Docker, okay, and they will give you kind of a how to sign in, what ID you can use here. You can use your Google, I think, and GitHub, or maybe your DockerHub ID. What is DockerHub? I'll tell you. But you can log in here, and you will get a prompt, Docker already installed, and you can play with it. I think they give for 4 hours or something. That is one of the options that you can use it. Okay, and for installation, if you're not reaching out to any correct documentation, what you need to search, install, or for anything, install Docker and press enter. Make sure that there are so many links you will get, but make sure that you go to the official link, docs.docker.com. Though I'm not saying the blogs and other things are wrong, but I somehow feel like anyone can write a Medium article, anyone can create a YouTube video, but the content, sometimes they don't know what they are teaching. Okay, so this you have to be little careful unless you are not well versed with Docker. So always follow the official document. So say for example, if I'm not sure how to install Docker, I'll go and search for install Docker. If it is coming from docs.docker, yes, I can trust it. I'll just click it here. So you can see this is the left hand menu will get all the related documentation, and here is the installation of Docker. Where you want to install Docker, you want to install Cent, Debian, Fedora, Raspberry Pi, blah 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 blah, so many things. Okay, so if I am interested in Ubuntu, I'll say click on Ubuntu. Okay, so this is like an install Docker engine on Ubuntu. What is Docker engine? I will let you know, but it's something like the main Docker daemon, the main process. Okay, so you can install it, they have mentioned first you need to uninstall the old version. So this is something for uninstall the old version. If you have anything, you can just, what is the beauty, you can just copy here, all the command will get copied. Okay, and you can just first paste it on your notepad. So first uninstall, it will just run a for loop, and it will uninstall all the previous version of Docker, Podman, everything. And then the installation command is this. You can just copy this, it will get copied, and this is the command. First you need to update, that is what we do. Then you need to install some certificate, add the repository, and this is the command to install your Docker. That's it. Okay, so these are a set of command 1 2 3 4 5 6 commands are there. You can just install it, or you can put everything in a file, run as a shell script. That is also fine. Okay, this is one of the way. This is official way to install Docker. Okay, install Docker. That is fine. All right, now I will tell you a little simpler way to install Docker. Okay, so what we are going to do is basically, let me see if my machine is ready. Just give me a second. Oh, I have not taken the IP address. Resource. Just give me a second. I need an IP address of my machine. Copy. Perfect. So it is a Linux machine that is running somewhere. Okay, it's a Linux machine, maybe running on Azure, AWS, on your local desktop, Google Cloud, Oracle Cloud, doesn't matter. It's a Linux machine. Treat it as a Linux machine. Okay. Alright, so this is a Linux machine, and let me change the prompt. Let me make it a little bit bigger. Or what I'll do, I'll become sudo su, I'll become root. I'll change the prompt. I'll say this is my Docker, and let me increase the font size, change setting. Alright, so Docker is just a prompt. Docker is not yet installed here. Okay, so we are going to learn how to install Docker. Okay. How to install on Windows, I'll tell you. Don't worry. First, let's learn on Linux. So, in Ubuntu machine, if you just type Docker and press enter, if Docker is not installed, Ubuntu will give you, like, you want to install, this is the command to install Docker. That's it. It will install Docker, because library, I mean the repository and everything is already added. From Ubuntu repository, it will get downloaded and you can install it. And what we need to do, first thing, you need to go and say apt -get update. Okay, just to make sure that everything is up to date. Second command, what you need to do, just need to copy this command, just one single command. I mean, you may ask, like, what is the point of, this is one of the way to install Docker. This is another way. Is this good? Is this bad? It's not like good, bad, or ugly always, because it's a lab. Okay, if I have to install for any of my customer or something, they will tell me like how to install Docker, because they have their own repository. They will say you need to use this particular version of Docker. So you have to be little flexible. Okay, but if somebody is not telling you, like, how to install at all, in that case I can follow this document and I can run one by one and we can install it. That's not a problem. But I'm telling you a little easy way. You can even the same thing, same command is, it will do the same thing. It will also install Docker. You just need to copy this one and clear my screen and run it. You want to continue? Yes, I want to continue. Preeti, it's putty, whatever you want to do. You know how to connect? Yeah, putty. For Windows machine, I'll come to that. Is Docker provided by Azure? I mean, Docker is not Azure or AWS thing, right? Docker is Docker company. The question is, can you install Docker on Azure machine? The answer is yes. Can you install Docker on AWS machines? Yes. The answer is yes. Okay. Docker as a service, if you are saying, that is not, basically there is another version of it, that is Kubernetes as a service, that we will see. Okay, because the way we are running Docker right now, nobody runs like this. So are you doing the wrong thing? No. What I'm trying to say, first if you want to write an essay, you have to start from alphabet, right? So we are learning the alphabets right now. Then we'll make a sentence, then we'll write an essay.
Kumar, can I ask one question to you?
Yeah.
I actually always have this confusion, like, for AWS we have the TCP instances, like it's like a virtual machine. It's basically, this terminology we can use, right? For TCP instance is the VM.
Yeah.
So in the particular VM we used to have our application installed, right? and we can run our application there. And we also, for the particular EC2 instances, we have our choice of operating systems there.
Right.
We can just choose that one. So I have also seen that for EC2 instance, I can install the Docker also in the EC2 instance.
Yeah.
So what is the additional benefit I will be getting if I don't, if I install the Docker there, I use an additional container inside that EC2 instance. Like what is the catch here actually? I just want to understand it.
Yeah, sure. I mean, that is good. So actually, let me explain you. How many of you are getting the same question confusion? Most of you? No, actually there is a couple of things. Let me take a side note somewhere because I don't want to explain this here. So what we will do, I will say. Okay, so there is a concept in cloud that you say they call it is bare metal. Okay. Bare metal is nothing but you will get a full hardware. Okay, you won't get VM, they will give you hardware, full hardware. They will say, look, go and get this hardware, full control. Okay, you have this hardware. Okay, and on this top of this hardware, you want to install any specific hypervisor, you want to create VMs, or you want to just install an operating system. That is your baby. How you want to manage it, you need to just take call on it. Okay, sometimes it is required. Some customer, I mean, when I was in AWS, like some customer come up with this requirement, I need a full hardware control. So in that case, cloud come up with a solution, something they say like, no, get this hardware and let's whatever the way you want to manage it. Then there is another concept that we called something known as VMs in cloud. VMs in cloud, like hardware you are not going to manage, that is managed by the cloud vendor itself. Okay, whether it's AWS, Azure, Google, Oracle, whatever it is. So this is your VM. I mean, in VM the hardware is managed by this. You will come up with, and if I talk about AWS, it's AMI or AMI. You can come up with an operating system image and install a VM. So you will get a virtual machine here based upon the operating system that you have selected. Okay, that is one. And in the same hardware, the VM hardware, there could be multiple EC2 instances. Okay, there could be multiple EC2 instances, and each one will coming with their own AME and AMI. But this EC2 instance belongs to customer 1, this belongs to customer 2, this belongs to customer 3. That is quite highly possible, and that is what happened. Okay, we don't know which hardware my VM is running, which hardware your VM is running, but we are getting access to this guy. Okay, what operating system, how to patch, how to backup, what application I want to run. That is your choice. You have to manage it. Then that another layer that we say like containerization. If you want to container on a hardware, that is going to be really costly for me or for you. Okay, I can manage the whole hardware and create container on top of it. That we can do this. But what we are doing right now here, we are taking a VM, because right now VM is just like a machine, a physical. Though it's a virtual machine, but it is so powerful and everything is there. So we can treat it as a server. Okay, we can treat it as a server, but it is not actually a server. Okay, for me, I can say this is my physical machine, but technically not. But I am treating it as a server, and on top of it, I am running container here. So I am further better utilizing my VM. That is what, instead of running one application, I can containerize it and run multiple applications. So I would say it's a better utilization, but you will get your answer in, like, when we talk about monolith and microservice approach, you will get your answer why we containerize an application. What is the benefit? What are the use cases for containerization? That we will understand. There is another option to run your application, that is something known as function or lambda, right? Lambda or function. That is where you have no control, right? I mean, you have no control of hardware, nothing. You just come up with your code and run it. Your code will be running in the form of function. What is hardware? What is operating system? We don't bother. So these are the choices given to you. What is best for me? Maybe some use cases, the best thing for me would be a bare metal. For some use cases, containerization is the best use case for me. Some use cases, the VM is good for me, and some use cases, the function is good for me. Which one is good, bad, ugly? Depend upon the use case. It's not always good, bad, and ugly. Okay. You got your answer. Who asked this question?
Yes, Kumar. So for better utilization of that, whatever the EC2 instance I have, so for better utilization of the resource, I will further containerize.
Okay, better utilization of hardware or resource is not always the criteria. It is one of the criteria. Okay, but there may be sometimes I have a requirement where I want to run a application that is going to run on container. So probably I can run my container application on a EC2 install VM rather than a physical machine, because it will be a very costly affair. Okay, so and again, I mean, if I have to make it like, if it is one bare metal, if it fails, if the hardware fails, I'm running on a single point of failure. So I can have multiple VMs and 10, 20, 30, and I can run small containers on top of it. My application is highly available and everything is there. So when we design some application, you will get your answer. But right now, because we are just at very initial level, so that is, I'm giving a very high level of understanding, this is what it is right now. All right.
Kumar, is it could be like that suppose, as you are mentioning that in a particular VM, you are basically, spawning up multiple containers there. Suppose I am going for multiple Docker containers, and I have multiple different applications are there. So each for just interoperability of the different applications, and to just remove the dependency over the
we will get this answer when we design the application. You will get this answer. What problem actually we solve, we will get this answer.
Okay.
All right. So we have installed. I mean, just to make a point here. I mean, I'm getting it like you folks have some question that is you may think I'm not answering, but it's not the point here, because I want to answer, but for that I need to cover some ground. Okay. So just wait for a minute. We have just a very simple definition of container. I have not told you like what actually is container, right? We have not yet reached there. So let me cover some ground, and I'll take all your question. By end of the day today, you'll get all your answer. Okay, that's my promise. Okay, so we have installed Docker here. So container got installed. Okay, so if I go back to my machine, and if I run Docker now, okay. How to know that Docker is installed or not? You just run Docker and press enter. Okay, this is one of the layman approach where we just run Docker, and just like in Git, we run Git, we get some information, right? This is all are the commands that I call verb. Okay, so these are the verbs. Okay, and this is also verb, all these verb. So it means that Docker is installed. What is a more professional way? You can say Docker -v. It will tell you like Docker version 27.5 install. If you also, you can do --version. That is also one of the way to know that Docker is installed or not. So if you are getting this output, it means Docker is installed. All right, Docker is installed. Okay, so how to run a Docker command? Docker command is going to run in the same way, like Docker plus some verb. Command is going to start with Docker plus some verb. And what are the options of verbs available that we have already explored? You just run Docker, and these are the some options available. So what I will do, I'll copy these things, okay, and I'll keep it at my notepad. Sometimes it is useful. You just keep it. It will give you one line explanation of this particular verb, what it does, what it will do, everything. You can just keep it here. So all these options are available. Okay, now in order to explain how to launch how to create a container, okay, for that the command is docker run. Okay, and if I go and see what run does, basically, so it says run line number 327. It says create, okay, and run a new container from an image. Oh, image, what is this? So let me copy this run. What run is going to do, run says, hey, I will create a container for you from an image. If you provide me an image, I can create a container for you. Okay, we have no idea what is image, but don't worry, we'll learn all those things. So the command is like, so it says you need to run docker run plus some image. Say for example, I'm giving this guy as an image, say nginx. I think, what is nginx? It's a web server that you can use it, just a web server, or maybe nginx has so many other roles like load balancer, ingress, a lot of things nginx does, but for us we can use it as a web server. So this is something like, docker run nginx is an image. From where this image comes and what it does, we will learn all those things, but first let's run this command and let's see what is happening. And also another command is docker ps. Okay, what ps does, let's try to understand. ps, yeah, line number 329. It says it will list the containers that is running on your machine. If you run docker ps, it will tell you that how many containers are running. Okay, let's verify it because we have a machine docker already installed. So what we'll do, we'll say, okay, fine, docker ps. Oh, so the output is blank. So it means that there is no container running. We just ran it docker ps and we got to know that no container is running. All right. Okay, fine. So I'll just mention the output here. This is what the current output is. Now I will install docker, one of the container, and we know that command is docker run, and I'm putting an option -d. Why I'm doing -d, I'll tell you in a minute. And I'm giving nginx. -d, I'm using it to run as a background, okay, background process. And I will tell you when you're not using -d what will happen. But just now we'll just run it as an -d just to make sure that it run as a background process. So if I run this command docker run -d nginx, and if I press enter, I'm getting some message. It says unable to find image locally. Okay, latest tap. It is downloading something. Okay, and extracting. It downloaded and extracted and says that a big number got printed in front of me. All right, let me copy this output because we will do the postmortem of this line by line. Okay. So this is what it is. Now let me run docker ps and verify that is there any container running. Docker ps. Yes, I got a container, right? So this says your container ID is this. If you match it, it is matching with some initial few character of this guy, right? 39B3C6 777 something. 39B3C6 777 something, right? It is matching. It says this container is created from nginx image. Yes, we have used nginx image. This container has command this some entry point. What is the meaning of it? We'll come to know that. It got created 19 seconds ago. Yes, almost 19 seconds before I run this command. Status, it is running from 18 seconds. That is fine. It is listening on this particular port. That is also fine. The name of this container is something very funny. We have not given any name, so that is why it will pick the name of its own. And whenever the container will pick a name of its own, it will always pick some funny name. So just ignore it. And how to give a name of a container, our own name, that we will learn. But right now the whole crux here is when we run this command, we got a container running. Perfect. So let me copy this output. Okay, and please, if you have any question, please hold, because I am telling you a very important story. Okay, this just listen like a story. It's very important story. Okay, we have created a container. So what happens? Let me draw a diagram. So what happens actually? This Linux machine. Okay, this is the Linux machine, and on this Linux machine we have installed Docker. Yes, Docker got installed. We have run apt-get Docker.io. Docker installed, and when the Docker got installed, we created a container on top of it and an nginx container that is running here. Right? This is what happened. This is nginx container is running on top of this machine. Yes, this is running. All right. Let me take a duplicate session of it. Same machine, I am taking another session. Okay, this is another session. Okay, I am giving my password. Let me do sudo su. Alright, so this is the same machine. I'm not changing the prompt here. This is Docker Lab, the name of the machine. This is the prompt here is Docker. And if I have to list down operating system process, what is the command to list down the operating system process? The command is ps. If you run ps, okay, it will tell you like the terminal, and if you run ps-aux, okay, it will list down all the operating system process. It is something like taskbar, right? Taskbar, you go and see what are the processes running, right? It is something like that. All these are the processes running on this particular VM. This is the PID, how much CPU it is running, blah blah blah, so many. This is the process name. So it is listing down all the process. What is the command? ps-aux. There is a command also ps-ef also, but aux is a better option that I generally prefer to use. So it is basically giving me the list of all the processes. Fine. All right. I want to run the same command again, but I want to filter. Filter is grep. I want to grep only those processes that are running with nginx name. Okay, nginx, right? I think grep small nginx. Okay, so this is basically what extra AUX will do. I'll explain in a minute. Okay, AUX will give better result as compared to EF. That's a Linux thing. I'll explain in a minute. First, let me cover this topic. Okay, so this is ps AUX, and I am grepping only those processes that has nginx processes. Can I see some nginx processes running? Yes, there are some process. That is the master process, that is the parent, and all these are the worker are the child process. Are you getting it? The master process has the PID, process ID is 3250, and the childs have the process ID 3299, blah 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 blah. Right? So one thing is sure, there is a process of nginx is running. Okay, fine. Let me go back to my terminal. Is the container still running? Let me verify it. Yes, my container is still running, up and running. Perfect. Now what I'll do, I'll kill this process. I'll stop this process. The command is kill, and the process ID. Okay, and you can do a forceful kill with -9. -9 is a forceful kill in Linux, and press the process ID. So what I'm telling you, what I'm going to do, I'm killing this master process. If master will get killed, child will automatically get killed, because child has a dependency from master over the master. So if I kill this one, okay, the command runs successfully. Let me run this command and make sure that is there a nginx process running. No, there is no nginx master worker process. This command that you are getting is just grep command, because every command will generate a process. So this is just the same command, but you can see the master is gone, worker is gone, nothing is appearing here. All right, let me make sure that my container is running. Docker ps. No, container is dead. Container is not running. So let me note down some observation. So first of all, we install Docker. Okay, when we install Docker, after that what we did, we launch, or we run nginx container. When we run nginx container running plus an nginx process also started running, right? This is true, this is correct, right? This is what we have observed. And after that, what we did, when we kill the nginx process, okay, the container also got killed. Is this correct? Right? This is what happens. So from here, can we say that container is nothing but an operating system process, isn't it? Are you correcting it? No, we have not manually installed nginx. We have started a container of it. Are you folks with me? Are you getting it? Anyone able to connect this? It's very simple, right? We install Docker, we install nginx container. When container started, nginx process also got started. We kill that process. We have not killed the container. We have killed the process. But the moment we kill the process, we observe that container also got killed. So it is nothing operating system process. So that is what the correct definition of container is. So this is correct. Okay. So the container is, so basically container is nothing but an operating system process, okay, that behaves like a virtual machine. This is what the container actually is, technically is. Now you may ask, okay fine, this is an operating system process, then how this operating system process will run my application code within it? You may ask this question, right? So because ultimately what we want to run our code within the container, and you just told me that container is a process. Then how an operating system process can run my code within it, isn't it? Actually I want to run. And what about the isolation? What about the security, right? So for that, I will explain you. I'll take you few steps back. Okay, and we will go to our college days. If you have learned a subject with name operating system, maybe you have followed any book, Tannenbaum or something. I don't know, but I love Tannenbaum. So this is one of the concept that I will just explain you. Actually, what happens? How operating system work? Let's try to understand how operating system works. How operating system works. Okay, very high level, we have something known as hardware, right? This is hardware. Over this hardware we have something, say for example RAM, CPU, most important thing, but there are a few other things, but RAM and CPU are literally most important things, and even our hard disk or whatever it is. Okay, and whenever you create an operating system, actually say for example you run any command, okay, or you run any process. Okay, so process, this is your process. Okay, this process actually need hardware in order to run it. Means it requires CPU and RAM. But this guy won't get directly access to the CPU and RAM. There is something in between that we call kernel. You may heard this sentence, kernel is the heart of operating system, right? So it's a kernel who gives process and access to operating system. Access to hardware. But process don't connect with kernel directly. There is another process thing in between that we call system call or syscall. That is a system process generate a system call. System call connects to kernel, and kernel provide whatever the hardware is required. Okay. If it is a process A that is created by something that you are some application. Similarly, if I have a process B that is created by some other application, the process B will also have the same method. Process B, this guy will generate something known as system call. Okay, and that is short we call syscall. Syscall will connect to the kernel of the operating system, and the kernel will provide the hardware. That is how any operating, the Linux operating system works. Okay. So the point here is, okay fine, how it is related to container. Now let me tell you a simple analogy, simple hypothetical situation. Just understand that I have two processes. I want to run two processes. Okay, and this hardware is my hard disk. Just imagine this is hard disk. Okay, this hard disk is there, and I have a two process. The process A requires some, say for example Python version 2, and process B requires Python version 3. Alright, because of any reason, because of any hypothetical reason, I cannot install 2 and 3 on the same hardware. Alright, just technically is it possible? Yes, it is possible. I can install any version of Python, multiple version of Python on the same machine. But just imagine, because I need to explain you a concept. Just imagine, because of any reason, either I can install Python 2 or Python 3 to my hard disk. Okay, if this is the situation, if I install Python 2, then the process A will generate the system call and he will get access to the hardware, right? And process A will be running. If I install Python 3, then only process B will get access to the hardware and only process B will be running. This is something is the challenge. Now, say for example, if I have something like, some property, something that partition my hard disk in such a way, okay, that partition my hard disk in such a way that, oops, sorry. This partition my hard disk in such a way that this part is unaware of, one part is unaware of other part. So what I can do, I can install Python 2 here, I'll say Py2 here, and I will install Python 3 here. Okay, I'll install Py3 here. So what will happen? When the request will come from process A, system called kernel will see this request is coming from process A, so let me allocate this portion of hardware. Similarly, for process B, go to kernel will say, okay, this is coming from process B, let me allocate this portion of hardware. In this scenario, can we run process A and process B and isolate the hardware if we have something like this? The answer is yes. We can run both process A and process B if we can partition the hard disk in such a way. Such a property of Linux is called Linux namespace. Okay, if I go and say Linux namespace wiki, so it says that, if you read it, or let me copy it. I'll just copy this one. This is important. So if you read it, right now, what it says, namespace is a feature of Linux kernel. It's a feature, okay, that partition a kernel resource. Kernel resource means hardware, CPU, RAM, kernel resource, such that one set of process means both master and the worker, because there will be master process and there will be so many child process, right? So this become one set of process. Just like in nginx we have master and few child processes. One set of process sees one set of resource, while another set of process sees another set of resource. This is exactly same happens at virtual machine, isn't it? This virtual machine will get this portion of hardware, right? This portion of hardware, that is what I told you, right? This virtual machine will get this portion of hardware, this virtual machine will get this portion of hardware, right? And they are running the something like this, their application. Similar thing is happening for a process. If you use the concept of namespace, what namespace says, I can partition your hardware in such a way that one set of process sees one set of resource, another set of process will see a different set of resource. They are not going to share the resource. This is what exactly we want. So that my process, who is actually a container, will start behaving like a virtual machine, because he will get a dedicated portion of hardware. And this hardware is not shared by this process. This is only and only belong to this process. This concept what container uses, namespace. They use, this is what I told you, Docker has not invented anything, they just use it what is available there. Okay, they use the concept of namespace and says, let's partition the hardware in such a way that you come up with your code and dependency. I will run it as a process and I will give you a kind of a dedicated hardware to run your application and make, use your application. Okay, they use another set of another principle, that another concept, that is we call C group. Okay, let me also tell you what is C group. C group wiki Linux. So what is C group? C group is nothing but a capping, right? Let me explain you first. Let me copy this. Oops, I copy again the namespace. What happened to C group? So what is C group? C group, also known as control group, is again a feature of Linux kernel. Okay, it is something that is available in Linux. Okay, feature that limits means cap. Okay, for cap accounts for isolated resource usage like CPU, memory, disk, IO, blah blah blah, so many other resources. So what it does, like say for example, if this is my hard disk, okay, this is my hard disk, I can create multiple partition in it. I can have this, we can do with namespace. Okay, I can have names, but what would be the size of this partition? That is defined by C group. Are you getting it? What would be the size of this partition? That is defined by C group. How big is the partition? Capping we can do this. Why? Because if one resource consume all the CPU, then what another process won't get any other resource, right? So that is also not good. So this is what internally container uses the feature of namespace and C group, and they make, by utilizing these feature, they make a process to behave like a virtual machine so that you can come up with your code. But your code ultimately, that we are saying running as a container, but it's nothing for operating system, is a process. And that is why the containers are so fast. Have you anytime observed like stopping a process, starting a process is going to take much lesser amount of time as compared to the whole operating system. If you shut down your machine, reboot your machine, it will take good amount of time. But you just stop a process, start a process, fraction of second, right? So that is why containers become very fast, because they utilizes it. They combine all these concepts in such a, I would say, in a better way, so that you are also running your application in the form of process, and the process behaves like a virtual machine. So answer of this question is nothing but kernel features, okay, like namespace, C groups, and few more. All right, are you folks with me so far? Let me take some questions here.